Hi, welcome to my channel. In the previous video, we discussed about some of the challenges of the machine learning, like insufficient quantity of training data, non-representative training data, poor quality data, irrelevant features of the training data, overfitting the training data. In this video, we are going to see underfitting of the training data. So, underfitting of training data is a situation in the machine learning where a machine learning model performs poorly on the training data itself. Simply it is called as a underfitting. Suppose for example, here the model is there. The model is unable to predict the class labels perfectly on the training data itself. Simply it is called as a underfitting. It occurs when the model is too simplistic or lack the capacity to learn the things and represent the underlying patterns and relationship present in the training data. Because of these three things, the model is unable to predict the data correctly in the training data itself. So why? It is a model is very simplistic or lack the capacity to learn the things from the data set, are unable to represent the underlying patterns in the data set, or it unable to find out the relationship present in the training data. So due to that one, we are going to get the underfitting in the data set. So as a result, the model fails to capture the complexities in the data and consequently exhibit the low performance on both the training data and new or unseen data. So because of this, we cannot get the perfect results. So the main cause of the underfitting includes insufficient model capacity. The complexity of the model is very low and limited training data. Because of limited training data and there is no feature engineering and over regularization. Because of these four things, we are getting the underfitting. So if the model is too simple, or has insufficient parameters, it may not able to learn the underlying relationship effectively. So with a small amount of training data, the model may not have enough examples to learn the exact patterns in the data set, complex patterns in the data set. So inadequate or irrelevant features can lead the model's inability to capture the essential patterns in the data set. So due to inadequate or irrelevant features can lead the model's inability to capture the essential patterns in the data. So the excessive use of the regularization techniques can constrain the model too much, causing the to underfit. So underfitting result in the poor predictive performance and inability to capture the patterns. So in order to overcome the underfitting, you have to follow different techniques. So one is increase the model complexity. Use the more complex models with more capacity to represent the underlying patterns in the data. So you have to increase the more complexity of your training model. And feature engineering. The feature engineering increase the feature set by including the relevant features or transforming existing ones to better represent the data. So feature engineering very important role in the underfitting. So reduce the regularization. If your model is using the regularization, then consider reducing its strength or removing it altogether. So increase the training data. If possible, obtain the more training data to provide the model with more examples to learn from that training data. So cross validation. Use the cross validation techniques to identify the underfitting and fine tune your hyperparameters to achieve the better performances. So it is very crucial to find the right balance between the model complexity and overfitting. So the goal is to create a model that generalizes well on the new data while still capturing the essential patterns in the training data. So for example, suppose you have a data set that includes the information about various houses like their sizes and corresponding sale prices. If you want to build a machine learning model to predict the price of the houses based on their size. So here data collection is you collect the data on the 100 houses where each data point includes the size of the house and its a sale price. Here the size of the house is independent variable and the sale of its price is a dependent variable. So model selection is you are deciding to use a simple linear regression model to predict the house price since it's a straightforward and interpretable method. So model training. You are training a linear regression model on the available data, try to find the best fitting line that minimizes the prediction errors. Our aim is to minimize the prediction errors. Okay. So now upon evaluating model's performances, it performs poorly on the training data itself. Why? The model predicted prices deviates significantly from the actual prices for many data points. So in this example, linear regression model is underfitting the training data. The reason is that housing price typically depends on the multiple factors like location, number of bedrooms, amenities provided by the corresponding location, and say many factors. However, the model you selected is too simple to capture the complexity of the relationship between the house size and the price. So as a result, it cannot be adequately fit for the data and predicted accurate prices. Thank you for watching our video. Thank you.